Hello everyone. Today we're diving into three-dimensional arrays. This is part 2 of our multi-dimensional arrays series. We'll explore 4 key topics today. First, we'll understand the structure of 3D arrays. Then, we'll look at memory layout and addressing. Next, we'll learn about traversal and operations. Finally, we'll analyze time and space complexity. Let's get started. Let's understand what is a 3D array first. A 3D array is a collection of elements arranged in 3 dimensions. These 3 dimensions are depth, which we also call layers, rows, and columns. Think of it as multiple 2D arrays stacked together, one on top of another. Let's look at an example. When we declare int ARR with 3 in first bracket, 4 in second bracket, and 5 in third bracket, we create a 3D array. This array has 3 layers of depth. Each layer has 4 rows. And each row has 5 columns. The total number of elements equals 3 times 4 times 5, which is 60 elements. Visually, imagine layer 0, layer 1, and layer 2. Each layer contains a complete 2D array. This stacked structure is what makes it 3-dimensional. Let's understand the 3D array structure and dimensions. When we declare a 3D array, we write int ARR with layers in first bracket, rows in second bracket, and columns in third bracket. For example, int ARR with 3 brackets containing 2, 3, and 4. Let's break down each dimension. The first bracket 2 represents the number of layers, which is the depth. The second bracket 3 represents the number of rows in each layer. The third bracket 4 represents the number of columns in each row. Now let's understand memory layout. How does a 3D array store data in memory? 3D arrays are stored in contiguous memory locations using row major order. This means all elements are stored one after another in memory. Let's look at an example. Int ARR with 2 layers, 2 rows, and 2 columns. Let's see how it's stored in memory. Starting with layer 0, ARR in brackets 000 having value 10 is stored at memory address 1000. Next, ARR in brackets 001 having value 15 is at address 1004. Moving to the next row, ARR in brackets 010 having value 20 is at 1008. Then ARR in brackets 011 equals 25 is at 1012. Now layer 1 begins. ARR in brackets 100 equals 50 is at address 1024. Similarly, other elements are stored in contiguous memory locations. Notice the pattern. Each integer takes 4 bytes, so memory addresses increase by 4. The entire 3D array is laid out sequentially in memory. Now let's learn about declaration and initialization of 3D arrays. There are 4 ways to declare and initialize 3D arrays. Method 1. Declaration only. You can simply declare int ARR with 2 layers, 3 rows, and 4 columns. This creates the array without initializing values. Method 2. Declaration with initialization. You can initialize all values at once. Write in ARR with 2 layers, 2 rows, and 3 columns, then use nested braces. The outer braces represent layers. Inside, braces represent rows. And the innermost braces contain column values. For example, layer 0 has values 5, 10, 15 in row 0, and 20, 25, 30 in row 1. Layer 1 has 35, 40, 45 in row 0, and 50, 55, 60 in row 1. Method 3. Partial initialization. You can initialize only some elements. The remaining elements automatically become 0. Method 4. Using loops to initialize. You can use 3 nested for loops. The outer loop goes through layers, the middle loop through rows, and the inner loop through columns. Remember, all dimensions must be specified at declaration. Nested braces organize data by layers, rows, and columns. Let's learn how to access elements in a 3D array using index notation. Let's use our example, int ARR with 2 layers, 3 rows, and 3 columns. Layer 0 has values from 1 to 9 and layer 1 has values from 10 to 18. Now let's access specific elements. To get the value 1, we write ARR in brackets 000. That's layer 0, row 0, column 0. To get 15, we write ARR in brackets 1, 1, 2. That's layer 1, row 1, and column 2. For writing elements, we use an assignment statement. If we write ARR in brackets 1, 2, 1 equals 19, this changes the values 17 to 19. Now let's learn how to traverse a 3D array using nested loop structure. To access all elements, we use 3 nested loops. Here's the syntax. We start with the outer for loop, which uses variable I to go from 0 to less than layers, which is 2 in our example. Inside this, we have the middle for loop, which uses variable j to go from 0 to less than rows, which is 3 in our example. And inside that, we have the inner for loop, which uses variable k to go from 0 to less than columns, which is 4 in our example. Inside the innermost loop, we can access element using ARR in brackets ijk. Now let's understand the loop execution order. The outer loop, using I, controls the layers. The middle loop, using j, controls the rows. The innermost loop, using k, controls the columns. The total iteration count is layers times rows times columns. Let's explore common operations on 3D arrays. There are 3 main operations you'll frequently use. Operation 1, update. To modify an element value, we use direct indexing. For example, ARR in brackets 1, 2, 3 equals 100. This updates the element at layer 1, row 2, column 3 to the value 100. The time complexity is big O of 1 because we access the element directly. Operation 2, search. To find if an element exists, we need to check all elements. We create a function that takes the array and a target value. We use 3 nested loops for layers, rows, and columns. Inside, we check if element exists in that array. The time complexity is big O of layers times rows times columns because we may need to check every element. Operation 3, find sum. To calculate the sum of all elements, we initialize sum to 0. Then we use 3 nested loops to traverse the entire array and add each element to sum. The time complexity is big O of layers times rows times columns. Remember the key principle. Direct access is big O of 1, but full traversal is big O of layers times rows times columns. Let's analyze time and space complexity for 3D arrays. Let's look at time complexity first. Operation 1, access element. To access or update an element, the time complexity is big O of 1. This is constant time because we access the element directly. Operation 2, traverse all elements. Using a triple nested loop to visit every element takes big O of layers times rows times columns. We must visit each element once. Operation 3, search element. In the worst case, we check all elements, so the time complexity is big O of layers times rows times columns. Operation 4, insert or update. Using direct index access, this is big O of 1. Now let's examine space complexity. For array storage, we need space for all elements, which is big O of layers times rows times columns. Let's see an example. For int ARR in brackets 3, 4, 5, the space equals 3 times 4 times 5, which is 60 elements. The memory required equals 60 times 4 bytes, which equals 240 bytes. Let's explore real-world applications of 3D arrays. First application is image processing with RGB images. Application 2 is game development for 3D game boards like Minecraft-like voxel games, 3D tic-tac-toe, or storing chess positions over time. Next application is scientific computing with data cubes. It is useful to store weather data over time, enables climate modeling, and helps analyze sensor data. It is also used in video processing for video frames. It stores multiple image frames, enables video compression, and helps with motion detection. It is useful in machine learning with 3D tensors. It is essential for neural network layers and batch processing in modern AI. 3D arrays are fundamental in multimedia, gaming, scientific computing, and modern AI and machine learning applications. Thank you so much for watching this tutorial. I hope you found this lesson helpful and easy to understand. If you enjoyed this video, please hit the like button. It really helps the channel grow. Don't forget to subscribe to the channel for more beginner-friendly programming tutorials and helpful tips. Feel free to comment your questions or thoughts below. I love hearing from you, and I try to respond to every comment. And don't forget to hit the bell icon so you get notified whenever I upload new videos. See you in the next lesson.